Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals involving modulus function, right? And here we are going to discuss this integral which is from 0 to 1, and here we have mod of sine 2 pi x dx, right? So here we'll find out the value of this integral by making use of the concept of periodicity of trigonometric functions, right? So let us call this integral as I, right? And here our integrand is mod of sine 2 pi x, right? So we'll denote this mod of sine 2 pi x by f of x, and our limits are from 0 to 1. Now, before moving further, let us quickly revise the property of periodicity of trigonometric functions. Right now, see, we know that the period of mod of sine x is given by pi, right? So the period of mod sine x is pi, right? And here we have mod of sine 2 pi x, right? So here we have a factor of 2 pi, right? So the period of mod sine 2 pi x can be obtained by dividing this pi by 2 pi, right? So the period of mod sine 2 pi x is given by pi divided by 2 pi, right? Because we know that if the period of a function f of x is t, then the period of the function f of ax is given by t divided by mod of a, right? So here a is 2 pi, right? And pi over 2 pi is equal to half, right? So the period of mod sine 2 pi x is half, and we'll utilize this concept of periodicity of mod sine 2 pi x to evaluate this integral. Now let us rewrite this integral as integral 0 times half, and here we can write 2 times half, right? So why we are writing the limits as 0 times half and 2 times half, we'll mention the property here, and here we'll write mod of sine 2 pi x dx, right? Now see, we have a very important property in definite integrals involving the periodic functions. So we know that if we have an integral like this, suppose here we have n of t, here we have m of t, and here we have a function, say f of x, right? And this function f of x has the period t, right? So here we have the limits n times t, m times t, where n and m are positive integers, right? So when we have an integral of this kind, then the value of this integral is given by m minus n times the integral from 0 to t f of x dx, right? Where t is the period of this function f of x, right? So our f of x is mod of sine 2 pi x, and we have just calculated the period of mod of sine 2 pi x as half, right? So that's why we have written here half, and here also we have written half, right? So now this integral can be written as 0 times t to 2 times t, and here we have f of x dx, right? So now if we compare this integral with this one, then we see that the value of n is 0 and the value of m is 2, right? So from this property, we can now write this integral as m minus n, so we have 2 minus 0 here, right? And multiplied with the integral 0 to t, right? So 0 to t, and t is half, right? Because the period of mod of sine 2 pi x is half, so here we'll write half. And for f of x, we can now write mod of sine 2 pi x and dx, right? So this integral is 2 minus 0 is 2, so we have 2 times 0 to half, and mod of sine 2 pi x dx, right? So now x varies from 0 to half, right? So now viewers, our next step is, see here the limits of integration varies from 0 to half, right? So x is greater than 0 and it is less than half, right? So we have now this inequality, right? So now we'll multiply throughout this inequality by the factor 2 pi, right? Because here we have 2 pi, right? So we'll get 2 pi times 0 is 0, and here we have 2 pi times x is 2 pi x, and when we multiply half by 2 pi, then 2 and 2 get cancelled, so here we have pi, right? So now 2 pi x, it goes from 0 to pi, right? And now if we see the sign convention of trigonometric functions, then see here we have 0, here we have pi by 2, here we have pi, and here we have 3 pi by 2, and here we have 2 pi, right? So 2 pi x, it varies from 0 to pi. So it means we are confined in the first and the second quadrant, right? So when we go from 0 to half, it means we are confined in the first and second quadrant, right? And we know that in the first and second quadrant, the sine function is positive, right? So now we'll utilize this property of sine function, which says that sine function is positive in the first and second quadrant, right? So now we can write mod of sine 2 pi x as simply positive sine 2 pi x, right? Because sine 2 pi x is positive in the first and second quadrant, right? So now this integral I can be written as 2 times 0 to half, and mod of sine 2 pi x can be written as positive sine 2 pi x, and here we have dx, right? So here we have also used the definition of mod function, because mod function says that mod of x is positive x whenever x is greater than 0, right? And for x we have sine 2 pi x, right? And sine 2 pi x is positive in the first and second quadrant when x goes from 0 to half, or 2 pi x goes from 0 to pi, right? So now we have a very simple integral, right? So we know that the integral of sine, say, ax dx is given by negative of 1 over a times cos of ax, right? And our a is 2 pi, right? So now this integral is 2 times, and we have minus 1 over 2 pi, and here we have cos of 2 pi x, and the limits of integration are from 0 to half, right? Now we can take this minus 1 over 2 pi factor outside, so we have 2 times minus 1 over 2 pi, and here we have cos 2 pi x, and limits are from 0 to half, right? So now this 2 and this 2 get cancelled, and we have minus 1 over pi, and when we take half here for x, this 2 and this 2 get cancelled, and we are left with simply cos pi minus when we take x is equal to 0 here, then we have here cos of 0, and now we have minus 1 over pi, and cos pi is minus 1 and cos 0 is 1. So this is minus 1 over pi times minus 2, right? So now I is given by minus 1 over pi, and here we have minus 2. So minus and minus, when we multiply both these factors, will get positive 2 over pi, right? So viewers, the value of this integral is equal to 2 over pi. So this is how, by making use of the concept of periodicity of trigonometric functions, the concept of mod function, and the concept of sign convention of trigonometric functions, we can evaluate these type of integrals, right? So the value of this integral I is 2 over pi.